Good evening, students. So, this is week 12 interactive session on traffic engineering course. So, this is the last session for this traffic engineering NPTEL course. So, today actually we have already finished our all the contents and their respective uh, discussions as well as the Q&A sessions in the last week till last week. So now we have one remaining week, that is today. So we kept it so that if students have any further more clarifications that is needed from me regarding the entire syllabus of this uh, traffic engineering, because your NPTEL exams will also be conducted, I think, during this April or April-May season, right? So if you have some last-minute questions or something, so you can always ask. So today I won't be solving any Q&A sessions because we have conducted 11 Q&A sessions for the benefit of the students. And today we mostly will look at it the entire syllabus, what are the topics that we covered in this NPTEL traffic engineering course. And in the meantime, if you have any queries or questions, you can raise your hand, right? So uh, today ideally I should not be talking, you should be discussing, or you should be talking more to me, but because you are not replying and many of you are not present, and maybe you may see the recorded lectures or may not attend the live sessions on a regular basis, so maybe I should start at least and give you the recap or memorize you that what are the things that we covered during this traffic engineering NPTEL course. So it is nothing new. Already you know. Already I discussed many things many times. So if you remember the modules, so initially we started with the initial concept, which is the introduction to traffic engineering, which mainly describes about traffic component and characteristics, right? And then your module B was regarding traffic stream and their characteristics. So first is traffic component, their characteristics, the basic traffic engineering and those concepts, and then the second one is the traffic stream and its characteristics. So basically where we talked about the macroscopic, microscopic traffic flow characteristics and different parameters and how they are usually calculated and all of those things, right? And also I think some headway distributions, because headway are generally the microscopic parameters, what is their distributions, and those things generally. And then I came to our module C or module 3, which is on shockwave and queuing. So basically we first three lectures were focused on shockwave theory only, and then the last two are the queuing. But as far as I remember, that we did not go into details in case of stochastic queuing. So actually it's a research area, so if you have any interest, you can search any good book of stochastic queuing, and also maybe you can refer to many advanced literatures in the similar domain. So then in the module D, we started discussing about the capacity and LOS. So there also we did not discuss the LOS of unsignalized intersection especially. Rest of the things we almost discussed. So we started with the highways, and then we came to our urban streets, and also the signalized intersections, but we did not discuss in detail the capacity and level of service of Uh, One is the your unsignalized intersection, second is your roundabouts. So those two, if anyone is are having any interest to know that how these are calculated, you may either refer to HCM 2016, I suppose, that is the latest version, and also you can check the Indian version of HCM for uh, to actually compare that how those are slightly different, the estimation methods are. So then in module E, we mainly focused on the signalized intersections or traffic signals. So there we actually focused on the basics of signal like phasing, green time, red time, and the level 1, level 2, level 3 intersections, and so on and so forth. And then actually we went to our estimation methods, how you design a fixed time signal during different trial cycle methods and other methods, right? And then also we talked about the signal progression, like how to optimize a signal along a corridor, not at an isolated intersections. Then the one way and the two way, those things we covered, right? And then next we actually went to um, slightly, we also covered the platoon dispersion model, how a platoon actually disperse along a within the signalized intersections. And once we finished the signalized part, we came to the car following theory, right? And also we developed that how your car following theory, different GM, like General Motors theory and other things, how those are related to the uh, your macroscopic model. So your car following is a kind of microscopic investigations. So how you investigate microscopically the traffic, and how you actually uh, discover the macroscopic, or discover the relationship between the microscopic and macroscopic characteristics, right? So that we discussed in detail, and also some of the basic concept of simulation, right? So that we discussed on car following. And then the next module we discussed about the traffic management measures. So here we talked about the access management measures, demand management measures, then uh, some bus priority measures also, right? So mostly we have concentrated around these three or four things, right? And also some kind of active traffic management measures, not only passive but also the active, like you use of ITS to basically manage your traffic, right? And then next means in the next module we started with parking management. So what are the different terms that is associated with parking, parking turnover, parking demand, parking supply, and so on and so forth, right? Parking classifications, on street, off street, and so on and so forth. And then after, and then we started the traffic safety. So we talked about the crash data investigation, then we talked about the road safety audits, then we talked about how your ML AI techniques are useful in basically developing the crash prediction models, not in detail but roughly, what are the type of models that you can use. So this was our whole overview of our traffic engineering. So it's a slightly heavy course actually, right? So it's a heavy credited course. So there are lots of materials which is involved. So that's why actually we kept this interactive sessions as well, so that people are on a regular basis, they actually hear that what are the things are there, how those are calculated. So there are less chance that you will be conducting, or you will be having any problems. But the things that are missing from the syllabus, is one is I told you the queuing, the stochastic one especially, and then if you see any kind of unsignalized, how to design unsignalized intersection, like how to determine the capacity LOS, right? So those are some of the things, even the roundabouts, that you can actually study on your own. And obviously we did not go into the details of ITS, intelligent transportation systems. So actually you cannot cover everything in traffic engineering itself, although it's an integral part of traffic engineering, but there are some interdisciplinary areas or interdisciplinary concept that also you should know, uh, in case of if you have to uh, know the ITS in a better way, not only the traffic engineering basic concept but also some different interdisciplinary concepts, like how a communication is established, like what is the lag and those things. Some computer science, some ECE people, they are also actually involved in this. So now if we uh, so obviously I told you that I would encourage that all of you must participate today, since it is a closing session. So I do not want to say many things, but rather I will be happy if you ask questions, and I will be happy to answer all of your queries. So anyway, that is there. But since I have to keep this class going, or so in that aspect actually, so we will again go through that what are the different topics in each module that we covered, right? So if you as I already told you that in module A, so there was uh, the concept is what is traffic engineering, right? Then why in the definition of traffic engineering multimodality came. So previously in western countries there are mainly uh, motorways. So motorways are generally consist of cars usually. So but nowadays your traffic engineering not only deals with motorways but also deals with cycling facilities, right? In case of urban context, and also the not only bicycle facilities but also bus stops and other things, right? So it's a multimodal in nature. If you have to manage, if you have to say what is a traffic engineering, right? Then also in India we are seeing that not only buses but also different types of vehicles like two-wheeler, then the mopeds, then the uh, trucks, small trucks, buses, mini buses, cycle rickshaws, e-rickshaws, cycles, many things are actually are moving with the traffic. So that is called the heterogeneity in traffic stream. So in traffic stream there are heterogeneity. Heterogeneity means their physical dimensions as well as the dynamic as well as the operating characteristics, means your acceleration deceleration characteristics both are different. So you know what happens if a fast moving vehicle is interacting with a slow moving vehicle, so your traffic stream gets interrupted, right? So those are the some of the issues that is there in traffic engineering nowadays. So then we came that what are the main objective, uh, why why we need to learn traffic engineering, what is the basic purpose of learning this subject, right? So see, one of the pertinent problem in India or in elsewhere also, that in roads there are traffic and there are accidents, right? So accidents means safety is compromised. So that means it's not only health hazard for the people, but also it's a negatively it is negatively impacting the GDP of the country. So as per the statistics, so young people are more dying, So if your young generation is dying in accidents, so see, it is impacting negatively impacting your GDP, right? So in one aspect, transportation engineering overall, it is deals with the mobility, movement of people. So how you want to move from one place to another place. So in ancient times we usually used to walk, right? So there are no roads, but we used to walk. So then we use many modes like bullock carts, horse rides, and etc. Right? And as you know, as humans invented the tires and shape like that structures, so then periodically or over time actually we develop different modes, and we are started to move. And as you develop mode, so you need better roads for moving, otherwise your vehicle won't last. So then we built road, we provide accessibility to different places. So mobility and accessibility were the primary focus of a transportation engineer. So then what about the traffic engineer? So now traffic engineer, see, people have to move. That is the basic point, right? And you should have accessibility. Otherwise, I cannot move. If there are no all weather road connectivity to a certain place, then even if I have a vehicle, it is very difficult for me to move. My mobility will get hampered. So I need to build road. So that's why mobility and accessibility is very important. So now once that is done, that okay, I have provided mobility and accessibility, and now what I am seeing, that safety is compromised. So now no, because see, you cannot say that uh, by providing mobility and accessibility, that's all, I cannot do anything more to it. You cannot say, because see, why you need to move, why people need to move, for various reasons, right? For personal reasons as well as for economic reasons. So that is the basic thing. Even if you do not want to build the road, that's okay, but still people will move. But now because you are building the road, you have made the regions more and more accessible with good mobility. So now your economic boom comes, right? Your industrialization and economic boom. But on the other hand, if your young generation is dying on those roads, so it is again not acceptable, right? And in any way, human life is more precious than your economic things, right? So that's why traffic engineer's role is to provide safety, right? So it's a human perspective. You have to you have to build a safe system. So then, what about the other object? Is it that the traffic engineering only deals with the safety? No, it has to be efficient also. So suppose you have built a road, but now there are too many vehicles are running. So now there are congestions. That means your travel time delays are increasing. So now people, how they will move from one place to another? If suppose a 10 kilometer stretch, and people have to spend 5 hours, suppose, let's say, so then it is not possible, right? So then what about the efficiency? So one of the aspect of the efficiency is you have to provide a smoother transportation systems. So you have to avoid congestion, you have to reduce congestion, you have to develop different routes, you have to check on the emissions levels, because your congestion is high, that means there are too many vehicles, that means your emission level will rise. Then uh, what about the suppose mm, what about the comfort? Suppose you have built a road, now it is not comfortable, it is a kind of bumpy road. So your safety, your now you are feeling discomfort, right? So you cannot say, it is not only that it is impacting, it is reducing the speed of the vehicles, but also it is very badly impacting the rider. So people will be discouraged to ride, right? So now that is called comfort. Now what about the convenience? So like, suppose you do not have your car, right? So you have your you are using the bus. Now is it that the bus is easily accessible to you? So that means if within a reasonable distance I am getting a bus stop, is it accessible to me? If it is so, then I can say that it's a convenient, right? It's a convenient, it will come. Bus stop is there and bus is coming. So then what about reliability? So is it that your bus is coming on time or not? So there are many aspects, right? So so those are the two things that traffic engineering are strive to do. Then also we actually discussed that our land use and transport now it is returned. So what about the what is the relationship between your land use and transport system? So see, suppose you improve your transport system at a particular area, that means you have improved the accessibility to the nearby land, right? So now as you improve the accessibility or improve the mobility as well, so now people will, because that land per parcel of land is easily accessible to me, now I want to go and live there, or I want to go and set up my business there, right? So if that is so, so then the demand for purchasing that land will increase, and as demand increases, because the supply is constant, so the price of the land gets increased, right? So now as your price increases, more and more people will settle there, and as you more and more people settle there, so people are using more and more vehicles in that nearby region. So now, even though you have a good transport system, the demand for transport system gets increased. So it's a cyclic nature. So as you improve your transport system, your land value gets increased. More and more people will be residing nearby, and then your need for good transport system will increase. So it's a cyclic in nature. Right? So then we come to the definition of mobility and accessibility. I was talking about mobility and accessibility only. So mobility means you have to move in a reasonable time. That's called the mobility in simple terms. Then accessibility means your land parcel or your bus stop or anything should be accessible to me. I so suppose there are no roads to a certain village. So how do I access that particular village? So if along a road there is no bus stop, so how do I actually access the bus? Bus will not stop there, bus will move because there is no bus stop. So that is the in a basic example of what is the mobility and accessibility, right? So even this mobility and accessibility concept, you can say for modes like different vehicle modes, car, aeroplane, a bus, and then also you can think of like a different streets. Streets means roads here. Suppose urban roads. So on the top of the urban road top tier, so in terms of mobility, so there are expressways, and at the bottom there is a local street. So local street is more accessible, but mobility is less. That is, the speed of the vehicles are less there. But in case of expressway, the main purpose is to provide mobility, not the accessibility. Accessibility is at limited locations only, right? So also, if you remember how those curves are there, how as your mobility increased, your accessibility decreased, and vice versa, right? So those actually we have learned, and how also we saw another graph how to compare the mobility and accessibility of different modes like car, buses, aeroplanes, uh, ships, and all, right? So then we went to the traffic engineering elements. So here elements means what are the different aspects of traffic engineering. So what are the, not the component, but what are the different themes that is involved in traffic engineering. First is, we all know, we all travel by road, so we all know what is the traffic. So now, what is the traffic characteristics? So how to know that what is the traffic characteristics? So how to quantify that what is traffic, what is a what do you mean by more traffic, what do you mean by less traffic, what do you mean by, like, we don't know, right? So there are three things usually: traffic volume, speed of traffic stream, then traffic density, right? So there are these three factors. Now, based on that, we can actually characterize traffic. So whenever you are saying that for A road traffic characteristics is this, for B road traffic characteristic could be something different, because their vehicle volumes are different, vehicle flows are different, or volumes are different, right? So those are traffic characteristics. How do you characterize a traffic? So then, performance evaluation. So now, suppose there are two roads. How do you know what is the performance of traffic characteristics along those two roads? How do you know which is bad traffic and which is called a good traffic? So to quantify this, actually there is a concept called level of service. So level of service A means very very good, level of service F means very poor, right? So you already talked about, like, level of service A to F. Then the facility design. So here, what do you mean by a facility? Here facility design refers to the geometric design. What are the number of lanes on the road? What is the width of each lane of the roads? What is the horizontal alignment of the road? Or is there sufficient side distance available? So those are called the facility design. Then the traffic control. So you have roads, you have junctions, and junctions are usually shared by every movements, like left, right, everything. So there are chances of chaos at junctions, right? So now there is a need to control those junctions using either stop sign or yield sign or traffic signal controls. So that is called the traffic control. Now the traffic operations. So how to decide that your traffic will move from A to B point towards AB, not BA? How do you design a one-way street versus a two-way street? When to design? So these are actually operations. How traffic will operate, right? So that is operations. Then transportation systems management. So so what do you mean by a transportation systems management? Is that suppose suppose let's take an example to understand this. Suppose there are high demand, means the number of vehicles that is traveling along a road is very high, right? So then you want to reduce the congestion. How do you want to manage that whole transportation systems? So one of the option is to use mass transit systems like metro. If you operate metro along that particular road, so there will be less number of vehicles because you are already shifting your demand to the from roads to metro rail. So that's how you design, or you can, one of the thing is how do you manage your transportation systems, right? Then integration of ITS, obviously, uh, in even if we install our traffic controls, so those are not all the times are dynamically operating, those are statically operating, and that's why uh, we we sometimes need actually in busy intersection the intervention of traffic police, right? So but if we can use our intelligent transportation systems in a better way by using dynamic adaptive signal controls and all those things, so we do not need to use our traffic police for those purposes, right? And also efficiency of the systems will be higher, also the cost will get lower. So those are some of the benefits. Everything will be automated. um, so, and there are many studies, not in particularly India, but in Western countries, where we see that how your dynamic system actually improve the efficiency. So now these are what are the different elements. So now what are the different components? How a traffic uh, stream is made of, right? So in a traffic stream, you are the driver, you are you are having a vehicle, so you are driving your vehicle on the roads. That is the all the things, right, on the road. So traffic component, one of the component is road user. I am the user, and my vehicle is the second one, and the road is the third one, right? And the control devices and the road markings, those things are the fourth one. So these are the different components which are actually interacting. I am on my vehicle interacting with another vehicle, interacting with the roads, interacting with the traffic control devices, right? And also obviously with the environment, because environment also has an influence on your traffic. So these are the components. So for road users, what are the different characteristics that has to be, that is actually playing a major role? Because you are the road users, if your vision is very poor, then obviously you may not able to see the traffic signs, even the next vehicles, and that may lead to sometime accidents and other things, right? Then not only your uh, visual acuity, which is your straight vision, but also the circumference of your vision, that is the field of vision, that is also another important factor, right? So not only your visual acuity is important, but also your field of vision important. Suppose you are driving a vehicle with a higher speed, and now suddenly you are seeing, you are realizing that someone just came and crossed the road, because you are on a your speed of the vehicle is higher, so you may not able to see, but you can perceive if your field of vision is good, right? So that's why sometimes older drivers are not that efficient, even they sometimes are uh, maybe victims of some road accidents and all. uh, so that's a research area actually, someone might go and do research. So these are the different road users thing. Even what is your perception reaction time? So as you age, your maybe perception reaction time will vary, right? So as you young, you can immediately see, perceive, and your perception reaction time will be less, and in case of old drivers, maybe sometimes it may be relatively high. So how do you actually design your road? Because there are different drivers with different characteristics, different perception reaction time, different fields of visions, different visual acuity. So you have to design a road in such a manner so that most of the people, you are designing for most of the people, so that no problems are occurring. But if you imagine, how do you accounts for that much of variabilities for, so it is not, it may not be possible all time to design your roads and other things for all of the people. So you have to some kind of average or something you have to look for, right? So here also we have those acute vision, fairly clear vision, peripheral vision. So those are what I was saying, different kind of visual characteristics. Then obviously perception reaction times. So so basically there is a concept of design vehicles and design driver. So already I talked about that there are many vehicles, many road users which are interacting with themselves, right? So that's why how do you account for those a large number of variations? So that's why actually people will come up with a concept of design vehicles which has a particular characteristics. So if we fall within that characteristic, there won't be not much problem. But if it is going beyond of this characteristics, there could be some difficulties. But design vehicles and design drivers are selected in such a way so that majority of the people uh, can be fall within the range without also stressing much about the cost of the road. Because if you account for all the drivers, then maybe your uh, for a good speed to maintain on highways, or good efficiency rather I can say, to maintain on roads, so the cost may be very high. So those are the things that a design engineer also has to think before uh, design this. So then we come to the functional classification of road. So generally here functional classification of road means we have to classify road based on the mobility and accessibility, because that is the main function of a road, to provide mobility and to provide the accessibility. So generally there are two kinds of classification that is given in Indian Road Congress or IRC guidelines. Based on that, one is the urban and second one is the rural, right? In case of urban, expressways, then your arterial, then your sub-arterial, then your district roads, major district roads, then your other district roads, and then your local streets. So these are the urban road classification, and then you come to the rural road classification. So in rural cases, there are national highways, then state highways, then okay. So in urban roads, actually I made some mistakes. So in urban roads, first is the urban expressway, then next is your uh, arterial, then your sub-arterial, and then third is your collector street, and then your local street. So these are the five main modes of roads on urban areas. In case of rural areas, the classification goes like this, starting from your national highways, then state highways, then major district roads, then other district roads, and then your village roads. So these are the five classification of your rural roads. So as you go from top to bottom, your accessibility increases and your mobility decreases. So then comes to your road markings. So how you should mark your road, where, when to use center line markings, uh, when to use uh, continuous center line markings, when you leave dots within the marking. So those are different kinds of marking schemes. In case of stop sign or stop, how do you mark the road, what is the color of that marking? So these are the different road marking schemes that is there in your content. Then traffic signs is also of different signs, different types. Regulatory sign, suppose speed limit may be a regulatory sign. uh, then your warning means, suppose stop is a warning sign. Then informatory means it's a one-way road, so that now one-way road may be a regulatory sign, whether the information means, uh, suppose this street or this road is going to this direction, that is the information. And uh, and the other road is going to the left direction, so those are the informations. So that is called the information design. So there are standards that are involved in designing of those signs, right? Then what is the road delineator? So road delineator means, suppose, how do you delineate a road? So you have your main carriageway, then you have your paved shoulder, and then you have your earthen shoulders, ideally. So then your vehicle should be within your carriageway, right? So you have to provide marking or delineate using something, either marking or maybe some radium lights or something you have to put install, so that your road is clearly visible even during the night time, because road alignment is also not straight all the times, it is like this. Then the traffic signals, what are type? There are mainly two types, pedestrian as well as the normal. Even in the normal traffic signal there are active and passive, and those things, fixed time, adaptive. So do you have anything to ask? So actually then we came to that what is a traffic stream. Already I discussed that due to different drivers showing different behavior, also your vehicle types are different, so their sizes are different, physical dimensions, length, width, height, and also their operating characteristics like speed, acceleration, deceleration, those characteristics are also different. So it made traffic stream a difficult thing to analyze, right? So uh, so that's why it is important to actually uh, study the nature of the traffic stream. So then what are the traffic facilities? So there are two types of traffic facilities, uninterrupted and interrupted. Uninterrupted means it's like expressway, so there are no access points, or there are a few access points. Are in case of interrupted, like in the urban roads, the intersections, so those are the interrupted traffic flow facilities. Then your traffic stream parameters, so there are macroscopic parameters as well as the microscopic parameters. Using both you can actually analyze the traffic. So microscopic means in a smaller scale or in a vehicle scale, in case of one or two vehicles, or in case of vehicle pairs like a time headway, space headway, and those things. And relatively in greater amount like traffic volume, traffic speed, traffic stream speed, those are actually falls under the macroscopic characteristics. So even your speed is spatiotemporal variation, modal variations are observed in case of macroscopic speeds. So uh, in case of temporal variation, so peak and a peak of peak, you can see that traffic volumes are changing or V by C is changing. We will see that different variations, right? In case of spatial, you must see that uh, your in one lane vehicles are speeding, but other lane is using as the slow moving lane, so there could be uh, lateral speeding difference. Even in longitudinal direction, suppose if you have varying width, so that time also your speeds will be different. And then also in different directions, because maybe along one direction there are many signals, and other direction there are no signals, so there will be speed variation in that aspect as well. Obviously your bus will move at a lower speed than your good high quality SUVs, right? So there are mode to mode variations which is observed. So because there are different kind of variations, so now if you want to measure the overall speed of a traffic stream, so you will find that it's a so means there are element of variability. So not only your average speed is important, but also what is the variation of your speed. Suppose your speed varies from 10 to 50, so your average speed is 30 and your standard deviation is 20, right? And on another scenario your speed varies from 30 to 80, so in that case your 55 is around what is your that is your average speed, and your variability is how much, 25. So both are important, right? Because if your variability is very high, then your traffic will be more as your volume increases, there is a chance that your traffic will badly perform, or there could be accidents as well, right? There are chances. So that mean variance relationship is very important. So in case of estimation of average speed, so there are mainly two types of average speed. One is the time mean speed, other is the space mean speed. So actually in a traffic stream, because we said that there are two types of vehicles that may exist. One may be slow moving, other one may be fast moving, and in between also there are different speeds of vehicles. So to account for that factor, you have to consider space. That's why space mean speed is actually introduced in contrast to the time mean speed. So okay, then also suppose uh, mm, suppose we have two traffic stream. Now we want to compare that is it that the traffic characteristics or traffic speed characteristics at the both locations are same or not. In that case what we can do, we can actually um, estimate the mean of those traffic speed between the two different roads, and then actually we can use statistical testing, because it's a highly varying thing. So so suppose in one sample you are finding your mean speed is 9, but in other sample your mean speed is 11. So how do you know that? So you have to take many samples, right, within a say within a particular segment, and then you have to plot it. So it's a statistical test to see that whether those means or even variances are highly or significantly different than different or not. If those are different, so then you will do something else, and otherwise that has to be remain same. So then also we came across the idea of grouped and ungrouped samples. So suppose your sample size is very high, like 1 lakhs. So now you know the speed of 1 lakh vehicles. So it is very difficult for you to analyze the 1 lakh samples by writing 1, 2, 3, 4, 5, 6, and so on and so forth. It is not feasible, right? So because in case of 1 lakh samples you have a varying speed, so now you start clubbing it together. So suppose the speed varying from 0 to 20, how many vehicles are there? Maybe 132, maybe 1032. So those are 1, and then for next is 1, then the next is 1, and then you take the mean speed of each of those sample as the representing mean speed. So in that way, the grouped samples are analyzed, and in case of smaller samples, we usually do it in a ungrouped manner. So then, so because we talked about the variability of speed and statistical measures, so generally, if we can know that speed is following some mathematical distributions like normal distribution, log normal distributions, or something, chi-square distributions, right? So if we know those distributions, or if we can confirm that our speed profile, our samples are following that distribution, so now I do not have to measure the samples mean and sample variation and other different aspect as well. So based on that, I directly say that what is the formula of mean in a normal sample, that I directly can use it for my purpose, right? So I will not go into the details. So there were many things like how to know that how your profile is actually following the mathematical distributions. So then actually we talked about the macroscopic and microscopic characteristics. In case of macroscopic characteristics, we actually first talked about the traffic volume. So traffic volume, you could say that okay, number of vehicles are moving, so it's a traffic volume. But see, the stochasticity is always involved in traffic. So if you measure traffic during different days, you will find that your daily traffic volume changes. Even if you fix a time period, then you try to see how many vehicles are coming during different days, that is also varying. So if you also analyze your traffic during summer and winter, the winter traffic will be higher usually. So there are many variations, daily, weekly, even within the day. So to account for these variations, there are different methods. So one of the method is you analyze your traffic for 365 days in a year, and then you average out. So that is the daily traffic volume, which is called the annual average daily traffic, right? So this is called the ADT. So now what is ADT, average daily traffic? So suppose it is very difficult for any agency or any people to count the traffic for that much of time, 365 days. So rather we can quickly 3 to 7 days we can do a traffic survey and then average it. So then actually it is called the ADT. So in a similar scenario, in case of AWT, annual average weekly traffic, we see that for each week within a year, we then average weekly basis, and then actually we calculate our AWT also. So then it is called the daily traffic volume. Then what about the hourly volume? So even during peak hour and during off peak hour, so your traffic volume changes, right? So that's why directional design hourly volume has been introduced. So because usually in the morning whenever you are going for work, so the flow will be heavy along that direction, because every people are moving towards the CBD area for work, and it is the exact opposite during the evening. So evening the opposite direction traffic will be high, because everyone is coming to home from your offices. So that's why along one direction at a one time the traffic volume will be very high. So that's why there is a DDHB factor which accounts the directional factor into the AADT, right? So what is the directional split of the traffic volume, and also what is the hourly traffic, because you know the ADT is the design, uh, it is the uh, total daily traffic. So now you need that what is the hourly traffic. For hourly traffic you need a factor of K, and K will vary. If it is a peak hour it will be different, if it is off peak hour it will be different. And in case of D, it is the directional traffic volume. Suppose the directional split is 70 is to 30. So then your one directional your split factor will be 0.7 and on other direction your split factor will be 0.3. So also it is observed that within the hour also the volumes are changes. If you analyze in a 15 minute period wise, so within even each minute it may be changes, right? So what is observed that generally in case of 15 minutes, within 15 minutes the fluctuations are very less in case of traffic, day by day fluctuations. So that's why we analyze the peak hour and then we analyze the worst 15-minute period, and then based on that we design our peak hourly volume and we use the peak hour factor to attain that peak hourly volume. Then we came to a one microscopic factor which is called the time headway. So time headway means what is the time difference or time gap between the two vehicles which can cross a particular standard reference point consecutively, two vehicles, what is the time gap between the two vehicles, that is called the time headway when vehicles are traveling obviously along a route. So then how your time headway distributions are. So whenever your flow is very less, means there are very low number of vehicles or lower vehicles or less number of vehicles are traveling. So in that case actually your time headway although your distance headway will be slightly higher, but your speeds of vehicle traffic stream will be very high speed and their distance headway will be something greater, but your because of the high speed your time headway will be lower, right? So in that case what type of distributions it is actually following? So it was supposed to follow the negative binomial distributions in case of low flow conditions, right? It is a random distribution. Then what about when there are more traffic? What about when there are intermediate traffic situations, right? So these are the different distributions that we actually did in detail we talked about. Then we come to the second macroscopic parameter which is called the traffic density. So how many your number of vehicles are crossing or are actually are contained in a unit length along a road. So suppose at a particular section along 1 kilometer of length, how many number of vehicles are present, which is actually if there are too many vehicles are present, that is called the jam density or the pack density, right? Also we talked about the optimum density. So what about your queries? I am looking forward to answer your queries. I was only saying these things repeatedly, but I want you to actually ask some questions. Sure. So there are no questions. So then I will continue. So then there are second there is we talked about the time headway. Then we will talk about the space headway. So space headway is nothing but the distance separation between the two consecutive vehicles crossing a particular road. So then what is the relationship between space flow and density? That we already know, that Q equal to your flow equal to K into V. K means your density, V means your vehicular speed. So that is called the fundamental relationship of traffic flow. And also we talked about how your speed density, speed flow, flow density relationship varies, and what about the modern freeway, how those characteristics are different for modern freeways. So those were actually discussed. Then also in case of speed flow curve, how your location influences. So if your location is near actually bottleneck, if your location is away from the bottleneck, so those how those curves are actually getting influenced. So the learning is, so whenever you want to develop a speed flow curve, you may not actually get the ideal curve, ideal theoretical curve. You may get one portion of the curve because of this spatiotemporal variability which is actually involved. So then the third module is about shock wave. Shock wave is what? Shock wave is speed flow density. So suppose your traffic stream is moving and there is a particular type of speed flow density. So now any changes in the traffic flow or any changes in the in the capacity of a road actually creates a new speed flow density state in that particular along that particular road. So that change of state which is occurring, so that change actually it's called the shock wave. So it's a, like you are traveling and then it's changing, so that is called the shock wave, right? That change is called the rate of change, is called the, not rate of change, rate of change is called the speed of the shock wave. So that change or transition which is called the shock wave. See, it's like a shock that you change. Suppose you are a you are so suppose relatively less traffics are there, so you are moving at a higher speed. Your traffic as a macroscopic, your traffic moves at a higher speed. Now suddenly there is a bottleneck, so you will feel a shock, right? So your vehicles will be traveling at a lower speed and your speed flow density relationship changes. So that is called a shock wave. Now qualitative analysis of shock wave means what are the different type of shock waves, what happens when the signalized intersection is there, what happens when uh, uh, your sudden bottleneck is there, right? Suppose what happens if you have a narrow bridge, so what happens. So those are the qualitatively what are the different type of shock waves. So shock waves mainly are different types, like forward moving, is it backward moving, is it creating congestion, is it dissipatory shock wave. So those are the different concepts that have been covered. So like shock wave at signalized intersection, then at a bridge and etc. Then quantitatively, what is the speed of the shock wave? So it's nothing but the dq by dk, that is the change of your traffic state q by k, how those changes, it is called the uh, quantitatively the speed of the shock wave. So then if you do a small changes, if you completely stopped like in a signalized intersections, and then again if your uh, traffic stream starts moving, so how your actually shockwave propagates. So those are different things that have been also covered in relative details. So then what is your traffic demand? So usually what we know, that if we measure that okay, these are the number of vehicles, that we usually consider as the traffic demand. but that is not the actual traffic demand, right? Because suppose there are congestions in the peak hour, higher travel time, delays, so people may not be actually want to choose that particular location for their travel, right? Or the particular location at a particular time. So there are some hidden demand that is always involved. So what happens actually, so suppose there are congestions and you actually made some adjustment and you improve the scenario, then also you will see that okay, even if you improve the situation, now also your traffic volume increases because now you have a better road. So people wanted to, those are those actually who are not traveling by that particular road previously due to congestion, now they will travel. So then you have to identify that what is the actual traffic demand. You cannot depend always on the only the observed traffic volume. So there is a difference, right? So then how your capacity is different than your queue discharge rate. So those are also have been discussed repeatedly. Then your deterministic queuing, your stochastic queuing, in case of your deterministic queuing, how your demand and supply varying. So when your demand is constant, supply means arrival rate is discharge rate is varying. So those are how different scenarios has been created. So those are actually discussed. Oh. So you do not have anything to ask? Tell me. Tell me some queries. Nothing. You can ask anything you want. So then in fourth chapter actually we talked about the capacity and LOS for, then we talked about what is a point, what is a segment, what is a facility, what are the corridors, and actually how you have to analyze the capacity and LOS of not only points in the intersection but also the segments, that is between the intersection, and the facility means you have to consider not only the mid blocks but also the intersections, that is called a facility. And then the corridor, which is consisting of not only one facility but also the multiple facilities. So then actually we talked about the capacity at base conditions. That's how you calculate. So you assume that your conditions is the ideal condition, and based on that there are formulas that is there. Based on the road width you can calculate the capacity, and then actually you apply the correction factors. So if it is not ideal, so what should be the correction factors, which is actually given in HCM as well as in the HCM, and that's how actually you calculate. So then there is a term called the quality of service. So what are the factors that is affecting the quality of service? And in quality of service there is a called another term that is called the level of service, which we actually talked about previously. Then we actually analyze the capacity of basic freeway and multi-way segments based on highway capacity manual 2016 USA, and also we uh, came across some different concepts which they developed during their based on their actually conditions. So once we know that how different concepts have been built during in US, so actually we then we come to the, I think, also the Indian HCM, which is not mentioned here, but actually we talked about how Indo HCMs like Indian HCM manual is different than the HCM which is developed in the USA. Hmm. So then this is the intersections. We talked about the what are the conflict points, what are the crossing or major conflicts, what are the turning conflicts, what are the minor conflicts. In the minor conflicts there are weaving, there are merging, there are divergings, right? So how why we want to design the intersections? So you have to give priority to some of the movements. You have to segregate in case of space and time the vehicles to avoid the accidents. So those things. So then you have to have a passive control or semi control, right? Passive control means they will, it's like a uncontrolled scenario, so they will automatically, you will see look at, they will look each other and they will control their uh, and then the semi control like a yield or traffic island, and then the active control like a signal or blend separations, etc. So then we talked about the side triangle, stopping distance. What happens if your side distance is not sufficient? You will be mostly involving in the accidents. What happens if you reduce your speed, right? So there are different scenarios that has been there. So then also we talked about the grid separator like clover leaf, trumpet. Also there are partial clover leaf, full clover leaves, right? So those are the different interchanges design which is actually necessary. So then also we talked about or we read about the warrants. So when at what scenario you need to have a signalized intersection from any kind of unsignalized one, right? So there should be some form of guidelines. So these are can be called as the warrants or the guidelines that you should follow before you actually change your unsignalized intersection to a signalized one. Then these are the different signal time controller, speed time, semi actuated, fully actuated. Then also we talked about how phase diagrams are actually drawn, then how ring diagrams are drawn, why ring diagrams are introduced, because traditionally we use phase diagram, but recently what happens, so you cannot segregate each and every movement all the time, so you have to use some kind of ring diagram. So maybe some little bit conflict you sometimes actually are acceptable, that is not actually creating any problems. So those kind of minor problems that is not creating, that will not create any problem. So you may use some kind of ring diagram to actually reduce your total cycle time and increase the efficiency of a signal. So in that case the sharing of signal, sharing of the same phasing for different kinds of mode for some times and off for some times, so that is lead to learning of ring diagrams. So then the movement group and lane group concept, uh, then the critical lane group, then the startup loss time, clearance loss time, YOLO interval. So there are different actually terms that we actually learn. Then we finally came to the abstract method of signal design, also the critical lane and time budget method of signal design. Although the most famous method is the Webster method, and there are many versions or modifications of this Webster method which is available. Then in case of also we talked about some HCM's concepts. Here we initially mainly talked about the actuated signal controllers and how they are better in handling the stochastic or variable traffic demand with time, right? Then we talked about what is the need of a signal coordination, because in urban areas generally signals are placed at a lesser distance within 200-300 meters. So if it is not properly signal coordinated and you are treating it as an isolated one, so it may not work efficiently. So your vehicles will uh, face more and more delays due to the presence of signals. So it is a very important and interesting topic, this signal coordination. So then also the different terminologies that is associated with signal coordination, splits like green splits, what is the offset, what is the force off, right? So what about the signal progression at one way, at two-way streets, right? What is the simple progression, then the flexible, then the reverse, then the negative ideal offset. So there are many things. Then in case of car following model, we just talked about these are the basic things. GM car following model is the famous one, so we focus on the GM car following model mainly. And then we talked about the traffic stability, local stability, asymptotic stability, then the Widerman confollowing model, right? Widerman confollowing model we talked because in most of the commercialized softwares like vSIM, they actually, although they are developed in Germany, so basically they are using this Widerman confollowing model very frequently. So we should have some knowledge about the flexibility of those car following models that is developed in Germany by Widerman, right? So then we talked about what is the actual system, what is a model, what is a mathematical model, what is a physical model. In mathematical, what is the analytical model, what is a simulation model, why we need a simulation model rather than an analytical one, right? Then what is the deterministic model, what is the stochastic model. Stochastic models are very important in traffic because traffic is not deterministic, it's a stochastic phenomenon in most of the cases, right? So there are always inherent stochasticity that is involved in traffic. And also we talked about some basics traffic micro simulation concept. So I will wait here for a couple of minutes before I go and just talked about the other part of this other remaining part of this traffic engineering course. If you have any questions, you just press the button on right in the chat box. Meanwhile, I will be returning within maybe 1 minute. So welcome back, students. So if you do not have any questions, I will continue the remaining portion. So in the remaining portion, we have the traffic management measures. What are the traffic management? Different kind of traffic management measures. How they are actually effective in what are their benefits, right? So these are the things. So then also, what is parking, what are the types of parking, what is the parking demand, what is the parking accumulation, right? So then we actually came to the last module, which is about the road safety. What are the risk factors of road crashes and fatalities? What are the causes reported in specifically in India? Then how human characteristics are influencing the road accidents, right? Uh, as in how to deal with the road safety issues. Some of the proactive measures are audits, perception surveys, simulation studies, right? Surrogate measures. And then the reactive ones are the crash prediction models, severity models, right? Descriptive analysis of the police related data. Uh, so what is the need of developing a good integrated road accident database, right? Because it may be because at least in situations like India, people are not actually storing the data in a good manner so that it can be used in future. So then also we actually talked about the concept of black spots, right? What are the different identification techniques? So how to use the crash data, what are the different aspects, what are the different model, not only crash prediction but also the severity of crashes, which is lead to even sometimes death. That is very important. What are the applications of different subcomputing methods, what are the different performance matrices, uh, then the different road safety audits, how road safety audits are conducted, what are the different stages of the road safety audits. Then recently the safe system approach has been uh, 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 this approach has been taken by the international organizations. What is their purpose, how they are seeing the road safety scenario, uh, how they are want to improve those scenarios. So these are the basics of the road safety. So this actually uh, brings to the end of our discussion to this recap. Basically, we did not do anything significant today. We just recap our memorize those things. Okay, so these are the things we actually covered. So now I hope that by uh, taking this or by conducting this weekly live session for consecutively 12 weeks during your NPTEL certification course, it helps you to better solve the problems, help you to sometimes uh, clears your doubts if you have any doubts, even if uh, many of the people are not joining during the live sessions. Maybe you are watching the pre-recorded videos and it is actually beneficial for you, because that was the main purpose, to benefit the students in any way possible. So I thoroughly enjoyed it, because I will be more happier if many people joined and interact, because that is somehow I feel that is missing. So, but anyway, students are always they are also very busy, so that is okay if they are watching it in the recorded form, which is uploaded in the YouTube later on. So that is from me today. or maybe that's what I can give you for this entire traffic engineering course. I do not have much to offer you, but even after this, if you have any queries, you can always email me. You will find my email, I think, in the institute website in IT Kharagpur as a research scholar, right? Under the Professor Bhargav Mitra, he is my supervisor, so you can see and you can mail if you want to reach me in any way, if uh, if you need some help and if I can help you regarding that. So beyond that, I do not have anything to ask for today. If you have any queries, you can say. Otherwise, we will we will say goodbye to the students as well as this traffic engineering course. Thank you so much uh, for joining, and even who are listening to my course even in the recorded version in the YouTube. And if it is help you even in 1% or 0.1%, I will be a happy person. So so if there is nothing, so I will be closing the sessions, and if in future anything is there, we will again meet. So take care, bye, and all the best for your NPTEL exams. Bye. I am just closing the session for everyone.